Hello everyone, I am Dante and this is the demo of the Graph-Greenifier tool. The Graph-Greenifier uses simulation to predict the performance and sustainability of a data center. In this demo, we will show how the Greenifier functions within the greater Graph-Massivizer project. However, Graph-Greenifier can also be used as a standalone tool. To use Graph-Greenifier, we need 4 input files. First, we need a workload that defines which PGOs need to be simulated and when. This in the Graph-Massivizer project is provided by the Graph-Optimizer and is provided in terms of a JSON file, which provides us with the information on which task needs to be executed, how long they will take, their energy usage, etc. Next, we need a definition of the available hardware. This is provided by the graph choreographer in the form of a JSON file. The JSON file provides us with which types of hosts are available, their core count, core speed, etc. Next, to predict the carbon emissions of a data center, we need information about the actual energy usage. To do that, we use carbon traces, which we gather from services such as ENTSO-E or electricity maps. These traces provide information about the carbon intensity at a specific timestamp in that region. Finally, we use an experiment file to define, basically take everything together. What do we need to simulate and how? In the Graph-Massivizer project, the Graph-Greenifier creates different experiments based on the provided input. This means that while we provided a specific workload and topology, the Graph-Greenifier will generate different ways of executing this workload. In this case, we want to simulate 4 to keep it within the time of the demo. This creates an experiment file where we can see again in JSON which workload needs to be executed, which topology, and in this case we see 4 different allocation policies. These policies decide when and where specific tasks are going to be executed and will thus cause for different ways of executing this same workload. Greenifier can be run directly through the terminal using by calling the executable and linking it to the experiment file we just made. When running, Greenifier prints some basic information so you know how the execution is going. During the simulation, the Graph-Greenifier gathers a lot of data and saves it to Parquet files. These Parquet files we can now analyze using a tool like Pandas. We will start with aggregating some results. This means taking all the data and making hopefully meaningful single digit or single results. For example, we can look at what was the runtime of the different execution plans. In this case, we see that they all finished in a bit more than 1 day, but some are a bit faster, some are slower. Similarly, we can look at the utilization, i.e. how much is each host used on average. Here we can see that the faster models also utilize their hosts more. Besides performance, we of course want to look at sustainability. Graph-Greenifier allows the simulation of energy usage, carbon emissions, and many more, which can give insight into how these different execution plans perform in that sense. We can see that, again, there is a difference between the execution plans, and while some models might be faster, they are also using much more energy. Similarly, for carbon emissions, we can see that there is a big difference. Besides looking at single results, we might want to plot the results to get a better insight of how the behavior of the different execution plans is. For example, we can look at the number of tasks that are being executed at a given time during the operations. There we can see that some have more peaks, some have more valleys, and especially the red line is interesting, where we can see a sort of on and off structure. This is caused by the load shifting that tries to delay certain tasks to better align with carbon intensity. Finally, we can of course also see how this will affect the power draw, where we can see that the faster models also use much more energy or power draw on average, which aligns with our earlier results about the energy usage. Finally, we would like to send this data, which we gather in an online fashion, to the graph choreographer, which we do by generating a JSON file. This JSON file contains the information about, for each execution plan, what, for instance, the energy usage is, but also more complex metrics, which we discuss in the 5.2, such as the sustainability cost rate. This is measured both for the full execution plans, but also for each of the tasks themselves. This was the demo of the Graph-Greenifier tool.